Today's episode of Future Says is proudly sponsored by Oracle. Oracle offers integrated suites of applications plus secure autonomous infrastructure in the Oracle Cloud. For more information, check out www.oracle.com. On today's episode of Future Says, we have Rajeev Verma, a data science senior specialist at Magna. His career has evolved from designing control systems to working on autonomous driving as well as complex manufacturing analytics. His philosophy of learn, apply, teach and repeat comes from a background which includes a PhD in electrical engineering as well as a Master's of Science in both mechanical and electrical engineering from the University of Michigan. Hello Rajeev and welcome to Future Says. Great to have you on the show.
Thank you. Delighted to be here.
So Rajeev, we've heard a little bit about you already on the introduction, but can you give us a bit of a deeper dive into your career progression and how you found yourself in your position at Magna today?
All right. So let me start with my training and I can then chart the evolution to my current job. So my undergraduate training is in mechanical engineering, which is basically, applied physical sciences, right? And from there, I went on for graduate studies at University of Michigan in control systems. And basically what that gave me was a systems view of the world, right? So let me just dive a little bit deeper into that and explain at a very high level what control systems is about, right? So with control systems, you take any system, right? It can be a physical system, biological system, or any other system that you're interested in. You define a task or behavior that you want this system to follow, okay? And from there, you identify the signals that you're interested in. You add sensors to collect or measure those signals. You add actuators to control the behavior of the system, right? And then on top of that, you add some computation. So it can be external computation or onboard computation along with algorithms, okay? And then from there you can calculate the proper actuation to apply and issue commands to achieve the behavior that you set out to achieve, right? So that's basically at a high level what control systems is. And now the question is, how has this helped me with my current job? So I found that because of my training, when I work on problems, I tend to identify the systems or the plant, in control lingo it's called the plant, that we are trying to influence or trying to work. And from there, I try to understand the operating principles of the plant. And I try to understand the ways in which we can model the plant, okay? How we can affect the plant, what we can measure from the plant. And in data science or machine learning, you can call this by various names, key process input variables, key process output variables, or independent variables, dependent variables. No matter what. And model in control science is differential equations, difference equations, and so on, state space equations. In data science or machine learning, it's more of black box. You can have neural networks or linear models and so on. But once you have all this figured out, you are then better positioned to predict the behavior of the system and then take appropriate actions, right? So that's, I think, what background in controls has given me. Now, coming back to my current job, which is basically around manufacturing. So application of data science in manufacturing. And I would like to take a step back here and just give a brief overview on industrial revolutions, right? So we have first industrial revolution, which started in mid-18th to mid-19th century, primarily in Britain, around use of mechanization in factories and steam-powered locomotives. Second industrial revolution, which was mid-19th to 20th century, which led to increased productivity through internal combustion engine use, electricity, telegraph, telephone, railroads, and so on. And that brings us to the third industrial revolution, which was mainly a result of computing, communication technologies, and robotics. So all of the machines that are being used, they have some computing on board, and it can make some decisions. Obviously, there are sensors, there are actuators, and based on that, you can optimize these machines at a local level, right? So that's what third industrial revolution was for. What this led to was proliferation of sensors and actuators, and also creation of a large quantity of data. Okay, but this data is at a local level. Now, these machines are generating a lot of data. It comes into existence and then it disappears, right? Let's say a laser welding machine. It generates a lot of data on back reflection, the airflow, the power, the path, and as soon as the weld is finished, poof, it disappears, right? So the fourth industrial revolution, which we are in right now, is all about harnessing the value of this data, right? So this is characterized by technologies like AI, artificial intelligence, advanced robotics, Internet of Things, 3D printing, and so on, right? So this is where data science plays a central role, right? And the data science in this context is the use of analytical techniques such as statistics, machine learning, AI to make meaningful decisions, right, based on this data. And the crux of this, and I'm coming back to my first point now, is that in manufacturing, we work with physical systems, okay? And that's where my background, mechanical as well as controls, comes into play, right? So I have found in my experience to having a systems view of the world is immensely beneficial. And making sense of manufacturing data is hard without understanding the physics of the underlying process, which means that either somebody from the manufacturing side or somebody in your team needs to understand the physical process and connect the dots with data science.
Brilliant introduction, Rajeev, and you make it sound like such a natural progression from understanding the domain to now there being data and you being maybe the best placed person or the best placed background to start to analyze that data. Is that something then you've seen on a wider scale in the industry in general? You said a mechanical engineering background. Is that something you've seen a lot of mechanical engineers moving into data science? And what about that wider Magna team?
So I have definitely seen that. So Magna has its roots in manufacturing, right? Manufacturing is in our DNA. So a lot of these manufacturing problems, they are realized at the floor level, right? At the shop floor level. And I have seen Magna engineers being extremely interested in learning data science and taking that route, coming from a manufacturing or mechanical background and then getting into data science, as well as from the other way around, right? So our team, for example, I'm a part of Magna Corporate R&D. Our department is called Data Analytics, Simulation, and IoT. We have a very small team, about 6-7 people, led by a really practical and visionary leader, Benjamin Saltzman. And all of our team members, for example, they have graduate or PhD degrees in data science or computer science, right? And they are all well versed with data science process, right? So this is essentially starting with business, a business case and problem definition, and then getting customer buy-in, connecting to data sources, data preparation, cleaning, modeling, analysis, evaluation of model, deployment, monitoring, and dashboard, right? So we need people with these skills as well. In a perfect world, we will have people from both backgrounds working together.
Brilliant. Can you say those steps just for all the audience as well of that data science process? It was great, the business case right to the dashboard.
So it starts with defining the problem. So this is essentially coming from the shop floor, okay, or line manager, and they are seeing some kind of issue on the shop floor, and they define the problem. But defining the problem doesn't mean that it should be addressed, right? Maybe there are easier way of addressing those problems. And that's where the business case comes in. You have to evaluate the business case. You have to evaluate what's the ROI and IRR and things like that. And if it's good enough, then you can work with the customer. Sometimes it comes from the shop floor. Sometimes maybe you have a larger vision of the solution set, and you can approach your manufacturing facilities and tell them, hey, we see this technology solving this problem. Would you be interested, right? So that's where you need to work together with the customer to get a buy-in. And that's where the actual problem-solving process starts, right? So then you start connecting to your data sources, you prepare the data, clean it, ETL, and from there, this is, by the way, the most amount of time you spent in the whole process, right? So if you have clean data, probably 80% of your work is done. And that's when you get into modeling, analysis, evaluation of the model, deploying the model. If your problem has been solved, you should have a clear-cut sign-off process from your customer. If the model is evaluated and it meets those criteria, then you get into deployment. And once it's deployed, then obviously, which is a big challenge in our industry, right? So monitoring and dashboarding and things like that.
Brilliant. Excellent step-by-step approach there. And can you tell us then about some of those business cases that you've been working on the last couple of years? What have been the priority ones which you've identified and had success?
Let me just give you a brief background on Magna, right? So I am I work with Magna. So it's one of the world's largest suppliers in automotive space. We are a mobility technology company with a global entrepreneurial mandate team and an organizational structure that's designed to innovate like a startup. So our CEO, Swami Kotagiri, he loves to say we are 65-year-old startup, right? And so you can imagine what kind of mindset that brings to the employees, right? We are proud of our world-class manufacturing capabilities, and you can imagine that we are utilizing data science extensively to empower our manufacturing operations. So in manufacturing, the common applications of data science, they are basically in predictive manufacturing, predictive quality, closed-loop process optimization, scheduling, demand forecasting, and energy consumption optimization, assembly line balancing, and so on, right? There are numerous applications. And because of the diversity of the products that Magna makes, we tend to get an opportunity to work on almost all of these problems.
And you mentioned then the steps, of course, of a problem, and starting with business identification. You say that the ETL takes up the biggest amount of that project. So if you take any of those particular projects, predictive manufacturing, quality, assembly plan balancing, demand forecasting, how long would something like that take? And what is the expectations up front? Of course, you can't get into numbers here, Rajeev, but what is the goal when you launch into a project? Is it saving money, making money? What's a success for a data science project?
So when it comes to money, right, normal matrices like IRR, rate of return, and things like that, ROI, return on investment, those are the matrices we go by. And in the end, how fast the project goes, it depends on how many resources you can throw at it and how eager your customer is to solve that problem. So in some cases, it can take only a couple of months. And in other cases where, we are working on creating long-term capabilities, it can take, several months, right? So that's how basically it goes. As I said before, we are going from Industry 3.0, which was third industrial revolution, into Industry 4.0, which is fourth industrial revolution.
And for people then that are earlier in the process, I mean, Magna, the scale of Magna is a 65-year-old startup. I love that, Rajeev. And for smaller companies out there that don't have those resources, do you have any advice or learnings that you've taken through your process and sort of advice on where they should start? I mean, amidst all these use cases, how should they take step 1, step 2, step 3?
I would say it all starts with understanding your data sources and your business problem. So even before data sources comes your business problems, right? So where are you losing money? Are you making too much scrap, or are you not operating your manufacturing lines at the capacity you planned them to run, right? So that to me is the starting point. From there, you need to understand your manufacturing machines and your infrastructure. Can you readily connect to your infrastructure and start collecting data? Or is there more work that's needed there? And that's where you will need to grow some OT routes. I'm sure every manufacturing company has OT side of business, right? There are people who are taking care of their operational technology. But connecting that to harvest the data that is being produced is a challenge. Again, data science knowledge, you either need a data scientist or you need people who are interested in data and they can start training themselves.
Yeah. So you mentioned some of those challenges there. And I mean, earlier in the conversation, you said it's a sort of a small team of 6 or 7 at Magna. Sometimes you see innovative tech and you bring it to the business. Other times the business brings challenges to you and you help solve those. how, I mean, you've very different backgrounds, right? You're experts in data science and controls and different innovative technologies, and the domains are experts in what they've been doing for 20, 30 years. How do you find that there's a cultural challenge in working together, and how do you get over that sometimes bottleneck?
Everybody speaks the language of business. And if you don't speak the language of business, it's very difficult to sell an idea. It needs to be both way. To me, that's the common language. If you talk to your counterparts in manufacturing and you're not talking business language, you're not going to sell your idea. So technology for technology's sake is not the best way forward, right? You need to come from using technology to solve real business problems, that are hurting operations. So that's basically, to me, that's the challenge. Once we bridge this gap, things start flowing smoothly. We can basically bring in our expertise in data and work with the manufacturing side on their expertise, and solve a problem, no matter how complex it is.
And come to a common understanding, or a common data literacy, or common business literacy. I really like that point as well, Rajeev.
Yeah.
You mentioned some of the areas that you've adopted data science already. You mentioned those use cases around quality manufacturing. Are there areas where adoption of data science and machine learning has been in some ways more difficult, and you've avoided those particular areas?
I wouldn't say avoided, but obviously there are several challenges within any company, right, that can hinder or slow data science adoption. So data quality and availability can be one challenge, right? So the processes are generating a large amount of data, but the quality and availability of this data may not be consistent. So there are older manufacturing equipment that don't have any data connectivity. So for this, you might have to work with the equipment manufacturer or add sensors yourself and gateways yourself. Use controls engineer to do that and get data, right? So that could be one challenge. The second aspect is really around structuring the data. At a manufacturer like Magna, every controls engineer might want to put data in a different structure and might want to approach the problem in a different way. So coming to terms on how you structure this data is very important, and that's where standardization comes into picture. There can also be, organizational resistance. So, and here I'm talking in general about traditional automotive manufacturing companies. They have well-established processes and practices which have been proven for ages, right? These are companies that have been in existence for decades. So implementing data science-driven solutions, it can be, it will require significant organizational adjustments. So these are things like upskilling your employees, redefining roles, and fostering a data-driven culture. Another thing is, as I mentioned, skills gap, right? So companies face a skill gap because older companies have people who were educated and trained a while ago, right? So when it comes to data science, it can be there can be a skills gap. So this is where companies can partner with universities to train their workforce, or bring in external partners to train their workforce, right? So, for example, Magna is partnering with the University of Toronto. There are a couple of other things as well that are important to understand. For example, digital transformation, it is a slow process. So if there are expectations that within 2 months or 3 months, the whole enterprise will be transformed and will start seeing results, it's not the right mindset to start with, for companies that are just starting now, right? It is a slow process. It's going to take time, but you have to start somewhere, and you better start somewhere. I mentioned the importance of business case that needs to be mentioned again, because if you pick the wrong business case, you're doomed to failure, right? You will not be able to sustain the speed of digital transformation. And then finally, within data science, there are issues around scalability, DevOps, MLOps, machine learning and AI. They are kind of relatively newer fields. So whereas in software engineering, DevOps is a very mature field. MLOps is getting there.
I think it's a very pertinent time to be having this conversation, especially the topic around upskilling. I've seen a lot of articles in the last couple of weeks, in the last couple of months about GPT, Rajeev, and the roles that GPT are going to take, and different analysts are saying 10% of roles, 20%, 30%. Quite frightening figures in terms of how automation can take people out of roles. And of course, the flip side of that is there'll be new jobs, of course, at the human interface of algorithms. But if you took yourself back to when you're launching into your career, or even now, an engineer that wants to upskill, like you said, what are some of those tips? What should they be doing to make sure that they're not a part of that statistic around data science looking to automate them out of what they're doing today?
I've put a lot of importance on education, right, throughout my career. And I think this is a topic I am very passionate about. People find time for things that they're passionate about, right? So I think developing passion for educating yourself and reskilling yourself, it should be, job number one for anyone, no matter where you're working. And that's investment in yourself, and you pay whoever you're working for through this investment, right? So make your education the priority, and you can tweak your education around what you're working on, so it helps you be more efficient during your day. But that should be priority number one, right? There are a couple of challenges around this, right? So the biggest challenge is corporate jobs. They expose one to narrow set of problems, right? So new employees come in, and when they come in, they bring in innovation, and they bring in new ways of solving old problems, right? And that's what we want every employee to be. The challenge is to sustain this innovative mindset, okay, with time. Because when you start working at a job for 1 year, 5 years, 10 years, you stop getting exposed to new ideas from the outside. So ChatGPT is scary if you don't leverage it. But if you leverage it, then it's your friend, right? And this is where successful professionals separate themselves, through continuous learning. But learning is different from person to person. The way people digest information is different from person to person. So there is some, room to play around here. For some, it's reading technical magazines or listening to podcasts or participating in conferences. But for others, it can be taking, courses, through, let's say, in-person or online courses that have built-in, evaluation test quizzes, and this can motivate them to digest their material better and cement concepts, right? So for me, for example, theoretical learning without practical application, it's a wasted time. Okay, so you have to have on-job learning and pursue education while you're working related to your field.
And that's exactly what you're doing, Rajeev. You mentioned Magna partnering with the University of Toronto. That sounds awesome. Can you tell us a bit more about that?
So Magna has a program. It's called Magna University, where employees can register themselves for courses. They offer graduate degrees as well. Again, you have to take professional education related to what you're working on. And it's a great opportunity for Magna employees to upskill themselves. They take classes during their workday. They get exposed to a lot of new, interesting ideas. And it's a win-win situation,
I can only vouch for that and agree with that, Rajeev. We at Altair, we created a course called AI for Executives, and all of our execs at Altair have now gone through that course. So I think especially now, we've mentioned ChatGPT, there's so much buzz and hype about this technology, and it's very difficult, even for people that work in this field, to separate fact from fiction and to understand what that I'm reading about is actually relevant and important for me to know for my job and for my career, and what is bluster. So now all of our executives, we're all speaking from the same hymn sheet. We're all speaking the same language. Like you said, we're all speaking that language of business, and not just speaking about technology for technology's sake, speaking about how technology can help us solve our business problems and help our clients solve their business problems. Yeah, so really, really important, that educational aspect. And I don't know how you do it, Rajeev. I don't know how you balance the business with the academia, but like you said earlier, it's important to do that to sustain things. You mentioned resources, Rajeev, the courses, the Coursera, the YouTube. Anything else for people out there that are interested in upskilling a bit more themselves in this field?
The pandemic, right? Due to that and work from home, I discovered walking. And I used to love reading books, but I discovered audio format consumption, right? So consuming books through audio format. So I have Audible and also podcasts. And I cannot tell you there's such good material out there. So I would highly encourage anyone who wants to retrain themselves to check out, audiobooks and podcasts. If you are into, audible learning, some people do like reading books, so for them it's fine. So I love, shows like Productivity Show. It's a show on Apple Podcasts that talks about how you improve your productivity. In terms of books, there are books like Skin in the Game. So Nassim Taleb, and anything written by him pretty much is actually pretty awesome. So check out all of his books. On software and data, there's a podcast called MLOps podcast. I really like it. I usually listen to podcasts at twice the speed because my retention is probably around 5%. And I am not really looking for, detailed retention of that material. It's just sometimes something really clicks. I'm going through a problem in my work life, and they mention some solution, and I just stop the podcast and make a note. And that happens several times in a week, if you can believe it. In general, around MLOps, DevOps, and the importance of that, there's a book I would highly recommend. It's called The Phoenix Project. It's a storytelling kind of book that would take you through all aspects and pains and pleasures of dealing with your MLOps and DevOps issues. On the data side, there's a book called Designing Data Intensive Applications that I think is a must read. I can keep going. I have a lot of personal psychology, timeless classics.
I think there's going to be a lot of walking done in the next while, Rajeev. We've a lot of audiobooks to listen to. That sounds great.
Exactly.
Rajeev, you mentioned MLOps a couple of times there, and your sort of passion for that. I mean, of course, you mentioned the analytical use cases you're working on, and now MLOps is increasingly a topic of super importance. It's what I see generally in the market now. I've been to the Gartner Summit quite recently in London, and there they've said that still only 20% or so machine learning models are put into production, which of course is never going to be enough in order to make this a success. So can you talk about the future of the data science space then? Is it MLOps? What else is coming down the road at us?
Yeah, so I would say that you talk about data science in general, right? There are some models that are not intended to get into production at all because you're trying to do root cause analysis. You're just trying to understand your process. But once you have the model, managing it becomes very complicated, especially if you want to scale, right? So if you are a person who's in charge of one line and that's all you have to do, and you're a very data, science-oriented person, you might be able to just, create a model, connect it to data, run it, and then update it as you go along. But if you are working on different problems, which, I'm lucky to be in that environment because of working for Magna, which is a large enterprise, and we see a lot of, different problems every day. That's where it becomes very important how you version your code, how you version your data, how you version your models, how you version your pipelines, and also how do you monitor them? Now you've deployed things. How do you monitor these things? So this definitely becomes kind of the sore thumb of the whole process, and something that's not very fun, but definitely needs to be done.
Do you think this is something that centralized teams like your own, Rajeev, will be doing? You'll be the, let's say, the core of MLOps and of custom model development and of quite complex things. And you mentioned the upskilling. Will those people in the domains and the lines of business, will they also need to do MLOps, MLflow and TensorFlow and these quite technical things? Or is there an easier, a lower barrier to entry for those people to start to do these things?
I think you are hitting upon two questions. This is more about, the term that I hear in the wild is data democratization, right? So if you democratize the data, how are those models going to be, managed in a sense? I think in a ideal world, just like software engineering, right? They have a testing team, they have a DevOps team, they have a deployment team, they have a software development team, and that's how they work, right? But in an ideal world, we will have an MLOps team that takes care of the deployment. So there's a lot of IT side of things there, right? There's infrastructure, IT infrastructure that needs to be spun up. Deployment needs to be done, and then management of those things also need to happen. Ideally, again, my own opinion, if you talk about data democratization or citizen data scientists, people at the shop floor who are trying to solve problems, they should have access to easily get to the data they are interested in. So if they are interested in, let's say, a machine and the data that machine is producing, and they come across a problem, let's say the cycle time of that machine is very high for all of a sudden, right? And they want to see, okay, is the heating taking place the way it was taking place, let's say 3 months ago when the cycle time was short? They should be able to get to those signals and, somehow plot those signals. You need to, also appreciate the fact that the newer generation, right, of people who are now graduating and entering workforce today, they have grown up expecting instantaneous access to information on anything that affects their life, right? It can be weather, their heartbeat, their sleep, whatever, right? And if we want this generation to work for our manufacturing industry, we need to provide them access to data, okay, relevant to their daily job.
You spoke a lot today then on the fourth industrial revolution and all the industrial revolutions. So when we look to the future then, we've already spoke a bit about data democratization. That could be the future, or certainly governed data democratization. Is that, let's say, the fifth industrial revolution, or what is the next big innovation within the manufacturing industry?
Fifth industrial revolution is certainly being talked about right now, but I'm just going to talk about from the business side of things, right? Again, as I said, data science to me is a path to get to a state of a business, right? So to me, in the future, we can expect, let's say, in 5 years, increased efficiency and lower production costs due to more prevalence of automation and robotics in manufacturing processes, integration of IoT and Industry 4 principles to get interconnected manufacturing ecosystems where the suppliers are connected to the, tier 2 suppliers are connected to tier 1 suppliers, tier 1 suppliers are connected to the OEMs. They're all working in unison. There's also technologies around 3D printing and additive manufacturing that would, we can start expecting those also to play more role in the near future. And, I think the pandemic and the crisis that just happened, it's also pushing everybody to, address supply chain disruptions and global economic shifts. So this will probably lead to some reshoring and distributed manufacturing, right? In 10 years, I would see these trends maturing more, right? So there will be, for example, smart manufacturing. AI, machine learning will be commonplace in manufacturing. Full integration of IoT and Industry 4, right? So seamless data-driven decision making across interconnected manufacturing facilities. Sustainable manufacturing practices will be a norm. So this is, essentially where we stop exploiting our environment and really start thinking about how we can come up with, ways of making products without disturbing it, right? So workforce transformation also needs to happen. I think it's happening now, but not at the speed that we really need it. So hopefully in 10 years, employee upskilling and retraining would adapt to new manufacturing landscape, and this would continue for the next 20 years or so. So that's what I would expect for the future.
And all those benefits, of course, are coming to Magna, to the manufacturing company. Accelerated production, I guess, reduced scrap, more automation, more sustainable production, like you said. To the end customer, then, to me, I'm buying a vehicle, Magna's parts are in the vehicle. How am I benefiting as a consumer? Do you have any thoughts on that?
That's a very interesting question. So where does the cycle start, really, the business cycle, right? It starts with a consumer wanting a product. Sometimes they're not aware of what they want. So in that case, you have people like Steve Jobs coming in and telling them what they want. But essentially, it's the consumer who consumes it. Somebody designs it, somebody puts it into production, and then goes to the consumer, and then it goes to waste, right? Or end of life or whatever. So with data, we can really understand how the product is being used by the consumer, and that would affect the design of the product itself, right? So far, that was driven by marketing people and getting feedback from consumers through questionnaires and so on. But we can now embed intelligence within the product that can give us feedback on how the product is actually being used, and so the consumers can expect a higher quality product that is designed to exactly what they want, right? So mass customization, for example. There's also benefits around cost. So you can expect all these efficiencies through smart manufacturing to bring the cost down, make the products higher quality while being sustainable.
Better products at lower cost.
Yes.
It's a win-win, Rajeev. Get back to work. We want to see these things.
Definitely. I'm working on it night and day.
Brilliant. Rajeev, we're out of time. I'll maybe ask one last question, but this is great content. Really appreciate your time. With all of this, we've already heard the excitement for the consumer, the excitement for Magna. What about the excitement for you, Rajeev? In this future of 5, 10 years, 20 years, what makes you, Rajeev Verma, most excited?
Okay, so as I said, I am pretty happy if I am able to work on complex problems and expose myself to things that I haven't done before and learn new things, pick up new skills to solve those problems. Right, that makes life exciting, right? So if you think about happiness research, right? So basically, the crux is setting small goals and achieving them on a regular basis versus going for long goals and waiting for years to achieve them. And the way I bring that up in my life is, as I said, I find learning new things or working on new domains enjoyable. I also find teaching and taking courses, another way of doing that, right? So to me, those are small goals that I set for myself. And I guess my bar for being happy is pretty low, but I keep happy doing it.
That's the most important thing. Rajeev, thank you so much for your time. We look forward to keeping in touch, and we'll see you soon.
Thank you, Sean.
Thanks for joining. Now next on the show, we have Johan Coley, Head of Innovation and Partner at Accurate Consulting. Hope to see you there.